we're going to continue to divide square roots, and we'll be looking at where we're actually dividing two full square roots. So in this case, the square root of 27 over the square root of 75. I'm going to do this problem two different ways, and there's not a good way to say when either method is better. There are just two different ways of approaching it. So here's method one. I'm going to put this back to be a single square root. This is the same thing as the square root of 27 over 75. That's just a square root property. And the reason I'm doing that is because this fraction will reduce. This fraction reduces to, since they're both divisible by 3, this is just 9/25. And this is really nice because I know the square root of 9 is 3 and the square root of 25 is 5. So this must just be positive 3/5. So that's one way to approach it. And this one worked out nicely, and I would say based on how it worked out, that was a good way to do it. Let me show you another way though, because there are some cases where this way might actually be better. So this time we're going to start by simplifying each square root individually. So I know in the numerator 27 is the same as 9 times 3, and in the denominator I have the same thing as 25 times 3. Well, in the numerator, the square root of 9 is 3, so this would become 3 root 3. And in the denominator, I would have 5 root 3. And in this case, they have a common factor of the square root of 3. So that common factor would divide out, leaving us with just 3/5. Same answer either way. It's really just a preference, and sometimes, situationally, one method may be more fruitful than another. Why don't you try one, and you can practice either way you want. The square root of 56 over 54. Write it down. The square root of 56 over the square root of 54. Hit pause and see what you can do with that. Alright, so I'm going to put these back together because I can see that this fraction might reduce a little bit, although I'm not sure if it'll be helpful or really helpful. Both of those are divisible by 2. So 56 divided by 2 is, what is that? 28. 54 divided by 2 is 27. So it helped some. Now I've got to simplify these independent. So I have in the numerator, since it's the square root of 28, well, that's 4 times 7. In the denominator, since it's the square root of 27, well, that's 9 times 3. The square root of 4 is 2, so this is 2 root 7 over 3 root 3. And that doesn't really go any further. Now there are some things that we could do to clean up the denominator a little bit, but we're not really worried about that yet. This is as far as this problem happens to go. It's not the nicest, but nice things don't always happen. Let's try something else. But really the same idea is in play. Let's consider the square root of 6y to the 5th. So now we just happen to have variables over the square root of 2y. Why don't you give it a shot? There's nothing really different about this other than the variables. Hit pause, see what you can do. Well, I'm going to put this back together into a single fraction. So this will be the square root of, I'm sorry, not 6, not 3. Let's try again. Of 6y to the 5th over 2y. But that fraction is going to reduce because 6 over 2 is just 3, and y to the 5th over y is y to the 4th. I can't do a whole lot with 3, right? That doesn't have a square root, but the square root of y to the 4th is y squared. So our final answer would be y squared times the square root of 3. And remember, just for say consistency's sake, we always put the stuff outside the square root first, and then the stuff inside the square root. Let's try one more like that. The square root of 14p to the 9th over the square root of 2p to the 5th. Hit pause and see what you can do with this. Well, hopefully you thought about putting this back together. So 14p to the 9th over 2p to the 5th. And when you simplify this, you'll get the square root of 7p to the 4th. The square root of 7 doesn't simplify, but the square root of p to the 4th is p squared. So this is p squared times the square root of 7. Hope you're doing well. Let me know if you have any questions.